Right. So we're still talking about net change, right? And accumulation of change, and how we said that the integral, right, is a way to calculate the amount of change, the net change that something is going through, right? Yesterday we did net change as it applies to distance traveled, velocity, and so on. Today we're going to do total consumption over time. And again, we're going to use the integral to calculate net change, right? It doesn't just have to be, velocity versus time. It doesn't just have to be distance. Integrals can be used to calculate growth, decay, consumption, okay? And anytime you want to find the cumulative effect of a rate of change, you have to integrate it, right? And these are like varying rate of change. So like, for example, if there's an amusement park, right? And people are, okay, so when you do have an amusement park, people enter at different rates, right? Like there's a huge rush in the morning, and then it might like dwindle at some point, and then there might be another rush in the afternoon, right? So the rate of people entering varies, but if you want to calculate how many people entered, that's an integral. You do that by integration. So take a look at this. From 1970 to 1980, the rate of potato consumption, because somebody calculated potato consumption, in a particular country was that function, millions of bushels per year. You guys know what a bushel is? Have you guys even seen a bushel? I've seen bushels of potatoes because I grew up in Lebanon, and we used to go to the country and farming and stuff. But you know, um, with T being years since the beginning of 1970. So 1970 is where our problem starts. How many bushels were consumed from the beginning of 1972 to the end of 1973? All right, so look at what we have here. What's important here? We have that the rate of potato consumption is this. Okay, this is the rate. All right, and for this, you are going to need calculators, by the way, for these. So that's the rate. And do you see how that is now a function that is not just, 6 sine of t? That is a more complex function. That's not necessarily possible to do by hand, right? So that's the rate from 1970 to 1980, and we want to calculate it from 1972 to 1973. So if 1970 is t is 0, then the total consumption is the integral of c of t, which is this. But now the time, right, from 1972 to the end of 1973, that's a total of 2 years, right? So it starts at t equals 2 and it goes to t equals 4. And that's really all you need to show. You put this in your calculator, not do this by hand, and then whatever you get, 3 decimal places, it's 7.066 millions of bushels. All right. Do you guys remember how to put the integrals in your calculator? Either chat me or raise your hand or something if you don't remember, and I'll go over it. Okay. Let me start my calculator and we can go over it. All right. So how did we know to do this? We have a rate and we want it to find, we have the rate of consumption, right? That's the language. What you're given is the rate of consumption, and then you want to find the total consumption. Okay, so when you have rate and you need to find total, integrate. And to integrate using your calculator, we would go to the home screen. The easiest way to do it, I think, is if you press the button next to the 9 to the right of the 9, you get this window, right? And here there's an integral. All right, and then we fill this in. So here I'm going to put in 2.2 plus 1.1 to the power of x tab dx tab, it won't let me do the tab. So let's go in the boundary. Let's put 2 and then tab 4, enter. There you go. All right. You have to be really swift with doing this on your calculator. Use the tab, put it in your calculator every single time, get used to it, because many of the questions on the AP just ask you to do this. All right.
I have a quick question.
Yeah.
Can you just say again where you got the 2 and the 4?
Yes, the 2 and the 4 came from here because it says to calculate it from 1972 to 1973. And if the problem starts at 1970, that's where t is 0. 1972 is t equals 2. The end of 1973, so that's like, December 31st of 1973. So we went 2 full years to t equals 4. Okay?
Okay.
All right. Next. So basically we're given rate and we need to find integral, right? Rate can be given as an equation, as a table, as a graph, and the integral is just the area. So you have to, whatever you're given, you have to find the area somehow. If it was an equation like 4, integrate. Now the rate is given to us as a graph like this. Integral means to find area. We do it geometrically. All right. So here the graph of the velocity, right? Again, velocity is rate of a particle moving on the x-axis is given. The particle starts at x equals 2 when t equals 0. So that's, the initial. Find where the particle is at the end of the trip. So we want final position. Final position, if this runs to 10 seconds, we want x of 10. Okay, so we learned yesterday that final position is initial position plus how much change there was, and that's the integral from 0 to 10 v of t dt. Okay. X of 0 is 2. That's what's given to us here. Plus. Now I need to find the integral here. Integral just means area. That means I need to find the area of this curve here, under this curve. All right. Let's see. We've got a trapezoid here. So the area is, the height is 2 over 2 times base 1 plus base 2. Okay. Here, this is a triangle, and the height is 2, so it's 1/2 times 4 times 2. So the area then is 9 minus 4. So x of 10 is 7. Okay. Next, total distance traveled by the particle. That's the integral from 0 to 10 of the absolute value of v of t. That means we just want the area under the curve, but the absolute value of it. So that's just 9 plus 4, 13. Okay. So here, rate was given as a function, and we integrated it, right? Here, rate given as a graph. Here, we have a pump connected to a generator that operates at a varying rate, depending on how much power is being drawn from the generator to operate other machinery. The rate in gallons per minute at which the pump operates is recorded at 10-minute intervals for 1 hour as shown in the table below. So here, rate is given as a table. Okay? The concept is the same. We have to find the area, but the method in which we do it is different, right? How many gallons? So we're given rate, and we want to find how many gallons, right? We want to find the total amount. Okay? And we are given rate. So it's the same every single time. Given rate, find total, integral. Okay, so for this one, we want to integrate. How do we do the integral? It's a trapezoidal rule when it's a table, okay? All right, so here, T is, let's see what's the height? 10, right? That's the distance of the intervals. So it's 10 over 2. And then we start with the first number, 58, plus 2 times the ones in the middle, plus 1 of the last one. And T is 3575. Okay, let's talk about units for a minute. The time here, the 10, is in minutes. These values were given in gallons per minute. So the total consumption, right, the total amount used is in fact in gallons. Do you see how it comes out in the math to the right units, right? That's how you know your math is right? Unit dimensional analysis. And all right, there are no units there, okay? All right, so that's that for this lesson.